Okay, so we're going to pick up where we left off at function decomposition. And this is when you want to take a function apart into two functions that you could compose to create that function. So h of x is this function, absolute value of 2x squared minus 5, and we want to break that up so that into two functions f and g, such that f of g of x is equal to h of x. So right here is what we're saying. We want to find two functions f and g such that if you put g of x into f, you would get this function h of x. So it's a little tricky and there's more than one way to do a lot of these. But basically what you want to do is look at the function you have and think about what it does to x. All right, so this function h of x, it takes x and squares it, multiplies it by 2, and then subtracts 5. So that's the first thing that it does to x. And then it takes the absolute value. So the two functions that you could use would be the function that takes x and squares it and multiplies it by 2 and subtracts 5. And then the other function you could use would be the function that takes the absolute value of something. So if you had f of x being the absolute value function, a function where whatever's in those parentheses, you just take the absolute value of it, and you let g of x be the function that takes x and squares it and multiplies it by 2 and subtracts 5. Then, if you take f circle g of x, which means f of g of x, and so you're taking f of 2x squared minus 5, and that, since we said that f is this absolute value function, we're putting 2x squared minus 5 into the absolute value function, and so that just means the absolute value of whatever's in those parentheses, which is 2x squared minus 5, which is what we want h of x to be, because h of x is f of g of x. So in this function decomposition, you're looking at a function and you're trying to take it apart into two functions that if you put x into this new function, it will do two things to it. And so when you are looking for the f and the g that you want to compose to get your h, you have to think about what is happening in this function. There's not just a set rule that you can follow to do these problems. You have to think about it, come up with the possibilities, and the way you do that is to think in your mind, what is happening to x in this function? Are there two things that are happening that I could use for those two functions I'm looking for? And so that is function decomposition, taking a function apart into two procedures. Okay, application of function composition. So at a popular website, the cost to download individual songs is $1.49 per song. In addition, a first-time visitor to the website has a one-time coupon for $1 off. A, write a function to represent the cost, C of x, in dollars, for a first-time visitor to purchase X songs. Okay, so this first function, if you put X in there, how many songs you're going to buy, it should tell you how much that is going to cost you. So this is the function, C of x, and the way we can talk about how much it's going to cost you to buy X songs is that, first of all, it's $1.49 per song. So for every song, you will multiply that by $1.49. So $1.49 times the number of songs you buy would be the cost, except that if you're a first-time visitor, you get $1 off. So you would just say minus $1. And so one thing you would want to say about this function, that x has to be greater than or equal to 1. I mean, you have to buy at least one song for this function to make any sense. All right, then sales tax for online purchases depends on the location of the business customer. If the sales tax rate on a purchase is 6%, write a function to represent the total cost, T of A, for a first-time visitor who buys $A in songs. Okay, so this is the function that tells you the total amount you have to pay when you spend $A at this website. It's going to be A plus another 6% of A. So the first one is the cost function. Second one is the total cost function. And now you want to find T of C of X and interpret the meaning in context. So T of C of X, you're going to take the cost function, which is, if we go back, it's $1.49x minus $1. So that is the cost function. You're going to take that and put it into the T function. So T of $1.49x minus 1. And so the T function tells you take whatever's in this parentheses here and multiply it by 1.06. So that would be 1.06 times $1.49x minus 1. So the T of C of X is telling you if you buy X songs, this is how much money you're going to have to pay, including your tax. That's what the meaning of T of C of X is. Evaluate T circle C of 10. All right, well, that means T of C of 10, which is equal to T of, you're going to put 10 into the C function. So that's $1.49 times 10 minus 1. You're putting that into the T function, so that's T of 14.9 minus 1, which is T of 13.9. And if we plug that into the T function, we are going to have 1.06 times 13.9. And that is going to be 14.734. But since this is money we're talking about, we would need to round it. But I think with money, you always round up. So it really would be 1474. But your book says that it is 1473. So to buy 10 songs, it would cost you $14.73. All right, the graphs of f and g are shown. F of x is the blue one, purple one is g of x. Evaluate the functions at the given value of x if possible. All right, so f plus g of 1 is the same thing as f of 1 plus g of 1. So we look for f of 1, that is when x is 1. What is the value of the function f of x? Well, the value of the function, remember, is the y value, so that's 4. F of 1 is 4. G of 1 is the value of the purple function and when x is 1. So if you go down here to the purple function, it's right there. The value, the y value of that function is negative 3. So 4 minus 3 is 1. That would be the value of f plus g of 1. F times g of 0, if we look at that, that means f of 0 times g of 0. All right, so f of 0, that happens when x is 0, and the value of the blue function f is 4. So 4 goes there. G of 0, the value of the purple function when x is 0, is right here. It is negative 4. And that is negative 16. G minus f of negative 3 is g of negative 3 minus f of negative 3. G of negative 3, here's negative 3 on the x-axis, that's what we're looking at. The g function, when x is negative 3, has a value of negative 1. And then we're going to subtract f of negative 3, and you've probably already noticed that the function f doesn't have a value at negative 3. Therefore, this doesn't have a value because negative 3 is not even in the domain of f, so you can't put it into this function, g minus f of negative 3. It's not in the domain of this new function. So you would just have to say does not exist, or you could say undefined, but it can't be done. You can't put negative 3 into the function g minus f because negative 3 is not in the domain of f. All right, so f of g of 3. So f of g of 3. If you look at g of 3, you got to start with the stuff in the parentheses and figure out what that is. So when x is 3, you go down to the purple function, and you can see that g has a value of -1. So we are putting into the f function the value -1. Now we just have to look at what happens at -1. When x is -1, the value of the f function is 3. So that would be the value here, 3. All right, g of f of 4. So g of f of 4. We have to find f of 4 first. So let me get rid of all these marks everywhere. So we go to 4 on the x-axis, and we look at the blue function f, and you can see that it has a value of 0. The y-coordinate there is just 0. So we're putting 0 into the g function. And when x is 0, right here, the value of the g function is -4. So -4 is what we get if we plug f of 4, which is 0, into the g function. Now f of g of 1, we look at g of 1. So we're going to go to 1 on our x-axis and look at the g function there and find out what its value is. The g function, when x is 1, has a value of -3. So we're putting -3 into the f function. So we look at when x is -3, what is the f function? We already said -3 is not in the domain of f, so we would say undefined. You can't put 3 into that function. Okay, so that's it for lesson 1.8. If you have any questions, please email me. And don't forget, we have a test next week.